Welcome back. This is Mr. Hassan's Maths channel. I'm answering question number 7 from the October-November 2023 Cambridge 9709 paper, Pure Mathematics paper 1. This is variant 3. And this question here is about functions. Now, the function f is defined by f of x 1 plus 3 over x minus 2, where x is greater than 2. State the range of the function f. Now, the range and domain of functions is something which is quite easily dealt with when you think about the sketch of what the function is. Now, this question is only worth 1 mark, so it doesn't really require that much, of a sketch and stuff. But sketching in general really helps you understand, functions. Okay, how to find the range and the domain of functions. Now, you have to first of all try to recognize what type of function it is. You have linear functions, quadratic functions, cubic functions, exponential functions, reciprocal functions, and so on. Now, this is a reciprocal function because you have x in the denominator. So it's going to have, its basic shape is going to be something like this. It's going to have an asymptote. And it's going to have, the parent function 1 over x looks something like this. Has these asymptotes here and here, which doesn't touch. But in this particular case, we can see the asymptotes for this function are not going to be x equals 0. All right, the asymptote for this is going to be x equals 2, because when x equals 2, there will be this will be undefined. So x equals 2 is one of the asymptotes. So if I do a little sketch there, x equals 2 is one of the asymptotes. So that's somewhere over here. And the other asymptote is when y equals 1, because it says 1 plus 3 over x minus 2. So it's like it's been translated 1 unit upwards. So it's going to be something like this. Okay, so that's x equals 2 and y equals 1. We can think of it y equals 1 because when we replace the y with 1, you end up with something like this. And if you try to solve this equation, you need to add 1 to both sides. You end up with 0 equals 3 over x minus 2. And if you solve this, multiply both sides by x minus 2, you'll end up with something like this, which doesn't make sense. It's a contradiction. So when y equals 1, you get a contradiction. So y equals 1 is a asymptote, meaning the graph can never touch that point. All right, so it's going to have, we can see it's going to be on this side and this side. Now we can work out where it crosses the x and y axis. We don't really need to do this. And you'll see why, because of the domain here. But I'm drawing as if there's no restriction on the domain first, just to show you how these things are drawn. So we can see when x is 0, what happens here? You have y equals, you have 1, and you have going to have minus 3 over 2. When x is 0, 1 minus 3 over 2, which is minus a half. So it's going to cross y-axis at minus a half. And when y is 0, which will be where it crosses the x-axis, you end up with 0 equals 1 plus 3 over x minus 2. So minus 1 equals 3 over x minus 2. So you can say x minus 2 equals minus 3. So x equals minus 3 plus 2, which is minus 1. So it crosses the x-axis at minus 1. Okay, minus 1 over here. So it's going to have this type of shape on this side, and it's going to have this type of shape on this side. So you can see from this, that's how it would look. That's how the graph of this function would look. Now, we have got a restriction on our domain, and that is x is greater than 2. So that means we don't need anything on this side. All of this can go. Okay, so all we have is the graph on this side. Now this is x equals 2. Okay, so we can see here that this graph will continue going higher and higher and higher and higher, getting close to x equals 2, never reach it. But it will never reach y equals 1. Okay, so it's the range, which is the range of a function, is all the y values it can take. Its range is going to be basically all the values of y it can take, which start from just above 1 and goes on to infinity. Okay, so it doesn't quite touch 1, and it goes all the way to infinity, carries on going on forever. Okay, so we can say the range of the function is f of x is greater than 1. Or we can say y is greater than 1. We don't say x, we say y. We're talking about the y values. So that's how you can think about this by doing the sketch, which is not really that necessary for this particular question. It's quite easy. And I'll show you how we can think about the range of this function by looking at the equation itself. So if you think about the range of this function looking at the equation itself, you can think of it like this, that x is greater than 2. So x starts from 2. So let's think of when x is close to 2. When x is close to 2. So we can say as x gets closer to 2 from the positive side, okay, from the positive side of 2, okay, from above 2, all right, so you can say that when x gets closer to 2, all right, then we can say f of x is going to be getting closer to 1 plus 3 over 0. Okay, as x approaches 2, then x minus 2 approaches 0. So this approaches 1 plus 3 over 0, which is going to be something. Now 3 over 0 is going to be infinite. So 1 plus something infinity. So f of x approaches positive infinity. So we can see that from here, as x gets closer to 2, y gets really huge, closer to infinity. And we can say that when f of x is approaching, or as x approaches infinity, because x can go on infinitely, then f of x approaches 1 plus 3 over infinity, which is basically, that's going to be 0. So f of x is going to approach 1, okay, but from the positive side, from above 1. Okay, so f of x approaches 1 as x approaches infinity. The bigger x gets, the closer and closer the y value gets to 1. So we can see, therefore, that the range of the function is f of x is greater than 1. So we can see that from just looking at the equation itself with its restricted domain there. All right, so there's the answer to question 7a. Now we're going to do 7b. It says obtain an expression for the inverse of f of x and state the domain of the inverse of f of x. So now, the inverse function. Okay, so first of all, let's call it y equals. The original function y equals 1 plus 3 over x minus 2. Now for the inverse function, what we do is we basically switch around the x and the y. So that's exactly what I'm going to do. I'm going to write the y as x, and I'm going to write the x as y. And then what I'm going to do is when I make this y the subject, I will end up with the inverse function. I'll end up with the inverse function. So if I make y the subject here, let's start off by subtracting 1 from both sides. X minus 1 equals 3 over y minus 2. And then we can multiply both sides by y minus 2 and divide both sides by x minus 1. So you end up basically these two swapping places. So y minus 2 equals 3 over x minus 1. And then we add 2 to both sides. So y is going to be 2 plus 3 over x minus 1. That is the inverse function. 2 plus 3 over x minus 1. And the domain of the inverse function is basically the same as the range of the original function. And we know that the range of the original function was f of x is greater than 1. So the domain we write was as x is greater than 1. The domain of the inverse function is always the same as the range of the original function and vice versa. Okay, so the domain is x is greater than 1. And there's the answer to part B. I mean, we could have re-expressed this as one fraction if you wanted to. That's fine. Okay, that's perfectly fine to do that. Now, some people over here, they actually did some silly things. Like, for example, some people, they wanted to make y the subject, and they said, let's multiply both sides by y minus 2. And, they basically they didn't multiply both of these by y minus 2, for example. They did some silly stuff. Well, at this stage, actually, it was at this stage over here. Okay, so I saw some people doing this. At this stage, they said, let's multiply both sides by y minus 2. And then what they did is they said, okay, x times y minus 2 equals 1 plus 3. It's like they completely ignored that there was a 1 there. they think that this y minus 2 is just multiplying the x. No, you multiply both sides of the equation by y minus 2. So you have x times y minus 2, and you have 1 times y minus 2. So it should become 1 times y minus 2. Okay, and then plus 3, because the y minus 2 cancels out when you multiply it. And then we can continue if we want to. It's a bit more hassle this way, but you can do this also. That's going to be y minus 2 plus 3, which is y plus 1. And then you can bring the y's together. So x, y minus y equals 2x plus 1. You can take y as common. So y times x minus 1 equals 2x plus 1. So therefore y equals 2x plus 1 over x minus 1. That's also an alternative way of writing the inverse function. You could write it in this form, 2x plus 1 over x minus 2. That's also possible. Okay, but don't make silly mistakes like that. That's a few students did that. All right, so that's the range, that's the domain of the inverse function, which is, that's what we had to find. If they said what is the range of the inverse function, well, that would be the domain of the original function, which would have been x is greater than 2. In that case, it would be y is greater than 2. They just swap over. Okay, now, then it says the function g is defined by g of x equals 2x minus 2 for x is greater than 0. Obtain a simplified expression for g of fx. Okay, so here they only want us to get an expression for g of fx. They're not asking us, does g of fx actually exist? They're not asking us to find the range or the domain of g of fx. They're just asking us to find an expression for that. So what we simply do is we take the function f and replace the x in function g by it. So g of fx is the same as doing this. It's taking the function f of x, which is all of this, and replacing the x in here, which is actually not that difficult here because we have 2 times, and then we're going to take what this is, which is 1 plus 3 over x minus 2, and then we got a minus 2. So it's 2 times x minus 2. X becomes the function f of x. Okay, so it's 2 times f of x minus 2. That's what happens. All right, so now we can just expand this. 2 times 1 is 2, and 2 times 3 over x minus 2 is 6 over x minus 2, and the minus 2 there by itself, they cancel out, so you're left with 6 over x minus 2. We can just say g of fx is equal to 6 over x minus 2. Okay, so they didn't ask us for the domain or the range or anything like that, just an expression for the function g of fx. So there's the answer to that question. Now, supposing they had asked us to find, say, the range of the simplified expression, the range of g of fx. Okay, then we'd have to think about, okay, what happens here? Okay, this is like an addition to this question. It's not really part of the question, so it's not part of this question at all. I'm just doing a little extra bit because sometimes they do ask that. So, and that's something that students do have some confusion about, right? So what we can do is you can say, okay, g of fx. If we think about g of fx, what's happening here? The x is taken and put into the function f of x, and then whatever comes out of f of x is taken, okay, and put into the function g of x. So instead of x, okay, what goes inside of f of x is whatever x is. Now, in this case, x must be greater than 2. That's a condition for f of x. X must be greater than 2, right? So x is greater than 2. So that's what goes inside of f of x. And what comes out of this, the output of this, is going to be the input of g of x. Whatever comes out of f of x is going to go inside g of x. X goes into f, and f of x goes into g. So what comes out of f of x? Well, we know f of x is greater than 1. The range of f of x with this condition given here is that f of x is greater than 1. Okay, and we can see that g of x, actually g of f of x will exist because the domain of f of x, the output of f of x is completely contained, within the domain of g of x. So what has to go inside of g, which is x is greater than 0, okay, this is completely inside that. Okay, this is completely inside that, so that's fine. Okay, there's no values there's no values that come out of f of x that g of x cannot take. G of x can take anything for x is greater than 0. That's this domain that's been given, right? So that means a function actually does exist. We can see that. And now we've got to think about what the output of g of x is. Now, what can go inside g of x is only the values of x which is greater than 1. Okay, so if you think about this, if you draw the graph of y equals y equals 2x minus 2, it's going to go through minus 2, and it's also going to go through when y equals it's going to go through 1. So it's gonna have this type of shape, going forever that way. Now, in this side, we're going to start from 0. So we can get rid of some of this stuff here. It's going to start from 0, so it's going to start from here. And x is 0, so we can see the range. Okay, the range of this function starts from, actually when x equals 1, okay, because we can put 1 in here. The input here has to be from 1 and onwards. So actually it starts from here. It starts from here, not minus, it starts from here. Okay, because when you put x equals 1 into here, what comes out is 2 minus, that's going to be 2 minus 2, which is 0. Okay, so when x equals 1, y equals 0. So it's going to start from here. So we can see that the range of this function, will be, you can say y is greater than or equal to, so greater than 0, not equal to, greater than 0, because this is greater than only. So we can see that what can go into function f is only values of x which are greater than 2, because that's how function f is defined. And what comes out of function f with this condition are all values which are greater than 1. So only values greater than 1 can be the input of g of x. And when you have the input of values greater than 1, then the output is going to be, for this, you can say g of f of x has to be greater than 0, as we mentioned, because when you put in the input of 1, okay, or above, this becomes, the output becomes 0 or above, okay, as you can see from the graph. So that would be the range of the inverse function. G f of x is greater than 0, okay, and yeah, and the domain of this function would be what's common between, okay, this and this, which is going to be, the domain would be x is greater than 1. The domain would be x is greater than 1, because what's common between what can go into the function g from f and what can go into function g by itself. So that would be the domain of the composite function, okay, and the range would be g of x, f of x is greater than 0. Now this last part here is completely, extra. Our answer stops here. All this stuff that I mentioned at the end is not part of the question. However, it's, sometimes is asked, and it's been asked more and more, commonly. So that's why I mentioned that. But we really don't need to even do that at all in this particular question, as I mentioned, because all they want is the simplified expression for g of f of x. They're not mentioning the domain, they're not mentioning the range, but that's how I explained a minute ago, is how you would actually find those things. So that's the answer to this question number 7. Okay, and yeah, it's just a little bit of an explanation here as well. Some people might not understand why you have 1 plus 3 over 0. Now, if you divide by 0, the answer is going to become really huge. Okay, so it's like undefined, but the closer and closer as this denominator approaches 0, when x minus 2 approaches 0, that's when x approaches 2, then you have 3 over something really, really small, which gives you a huge answer. If I divide 3 by, for example, 10, I get 3/10. If I divide 3 by 1, I get 3. It's getting bigger. If I divide 3 by 1/10, I get 30, which is even bigger. If I divide 3 by 1/millionth, I get 3 million. So the smaller this number becomes, okay, the closer it gets to 0, the bigger the output is. And similarly, when you divide by something really big, you divide a number by a really big number, okay, you end up with something really small. Okay, so 3 divided by a really huge number will be so small, it's insignificant. All right, so 3 divided by infinity is going to approach 0. So then this whole expression approaches 1. So that's where that comes from, in case you're not sure about that. Anyway, that completes this question here, question number 7 about functions. It's one of those questions where a lot of students do have issues with, especially when it comes to domain and range. But hopefully, with a bit of practice, that will be sorted out. So here we have the playlist for this particular paper, October, November 2023, from this Pure Mathematics 1, 9709, variant 1, variant 3, sorry. Other questions from functions in general can be found in this playlist. This is from Cambridge Functions Questions from P1. And you can subscribe to my channel by clicking on this link, and you can watch the video linked here. It tells you how to use my channel to find what you might be looking for. Thank you for watching, and see you soon.